Today we have topic 6.1 parallelograms. We will define a few key terms such as a quadrilateral and a parallelogram. We will also define what a diagonal is, and we will make conjectures about our parallelograms. Alright, so let's get to our notes. And in our notes, first portion of it, we have our terms and our definitions. It goes ahead and defines it for us, and we're going to draw a sketch for that. So, quadrilateral. Definition: a closed figure formed by four segments intersecting at their endpoints. Big key word here, endpoints. So, let's sketch a few figures of such. There's one. Doesn't have to have the exact same lengths on our sides. You can also have just a simple basic four sides. They can be running parallel, and then we can have a shape that is concave, which we learned in our last bit of our lesson. Concave figure, but this is also made up of four sides, hence the term quad, and they intersect at their endpoints. All of these three examples do such. Alright, a parallelogram is a quadrilateral in which opposite sides are parallel. So whenever you see this in any of our notes and any of our assignments, you will see something that will have something similar. You will have, and granted my artistic abilities are not the best, but we will have this as well as our arrows, which will indicate that these lines are parallel. And then these will have one as well. We've got one here, and similarly on the other side you also have two arrows. So, there is a parallelogram. Diagonals. Segments joining opposite vertices in a polygon. So, I took a figure, and I was going to draw the diagonals. Move that little mark I made. Diagonal will be right here. These two are diagonals. Granted, my line's not straight whatsoever on here, but what they are is they're segments. So imagine that they were straight. And what they're going to do is they're going to join the opposite vertices in the polygon. Alright, so let's look down the page at our examples. Example 1, the parallelogram at the right has four vertices. They are, so we're going to name the vertices. We're going to name these points right here where they all meet. 1, 2, 3, 4. So we're just naming the points. M, N, P, and Q. Alright, so now it's looking at the parallelogram, and it's asking how to name it. Now when we name it, we use shape, which you can see right here. This is where this comes from. And here it is. Here's our parallelogram. It's already pretty much named for us down below. MNPQ. That's the name of our parallelogram. The opposite sides. So we're going to look at two sides that are opposite of one another. I'm going to first look at the MN. If they're opposite of one another, they're going to be the ones they're going to be given away to us by which ones are parallel. So we have MN, and we also have opposite of that our PQ. But then we also have two more. We have NP and MQ. Alright, opposite angles. Okay, so now we're going to be looking at the angles which are opposite of one another. Opposite is directly across from. So here we have, let me go ahead and put angle M. Now which one is opposite angle M? It is angle P. And similarly, I'm going to start with N. Go down here the opposite, which is going to be Q. So we have angle N and angle Q. Alright, consecutive angles. Now, whenever it's talking about this consecutive angles, it's going to be which angles, if we followed it around this direction or this direction, either way really, which one comes next. So let's start at N. N's a good one for us to first begin with. We're going to say angle N. Now, if we go this direction here, we're going to run into angle P. So there's two of them. Now, let's also start with angle N, and let's go this direction. We have angle M. Alright, so we have started there, and if you go MN, angle M and angle N, you're saying the same thing. So we really don't have to start here or here to go back. But if we start here at this Q, we say the angle Q, and we can go both directions. We're going to head this way, angle M, and we'll head up that direction. So angle Q, angle P. Now this takes care of every one of those. PQ, is it in here? Yes. QM, yes, we wrote that down. MQ, same thing as right here. So this takes care of all of our consecutive angles. Alright. Now, let's see, what do we have here? The diagonals. If we were going to draw a line, let me grab another color for this. If we were going to draw a line from there to there, what line would that then represent? We would have MP. So that's a diagonal. Also, we start here, we come all the way down and across, we have NQ. So, there we have it named. We found the opposite sides of one another, the opposite angles of one another, consecutive angles, and our diagonals. Alright, so now let's move to the second page of our notes. And we have here parallelograms have 5 properties. They are the opposite sides are parallel. So let's mark this. The opposite sides are parallel. So, and I'm going to just make some quick arrows here for this. So let's mark what we know. We have opposite sides are parallel. There's 1, 2 on this side, and let's go ahead and jump over here. We've got our 1 and our 2. Alright. Our opposite sides are congruent. Okay, so if this side is congruent now to this side, we can put 2 over here because whenever we're talking about our opposites. Alright, so now we've marked our opposite sides are congruent. Opposite angles are congruent. So if I put one line here, we'd have to go opposite, and then just 2 here, which goes with this angle. Alright, so we've done our opposite sides are parallel, our opposite sides are congruent as well. Our opposite angles are congruent. Let's see what else we have. Consecutive angles are supplementary. So if we come out here to the side of this, we can put right here, this is equal to 180 degrees. Alright, we can say these two angles right here add up to 180. Just the same, these two can be that way, these two and these two as well will both add up to 180. And lastly, we have for us that our diagonals bisect each other. So, if our diagonals are bisecting, if we have this diagonal here and this one bisects it, remember what we learned about bisecting. That means these become congruent. Now, we also have this one that gets bisected. So, there's a lot going on with this. But by marking it, we can see that these two are congruent. These two angles over here are congruent, or two segments, excuse me, are going to be congruent. We can add up here to get 180. We can do that all the way around. These consecutive two add up to 180. These two angles are complementary, as well as these. This side and this side are congruent, as well as this side and this side. They are also congruent to one another because they are opposite, as well as the opposite sides being parallel. So that brings us down to our example 2. 1 starts out, name the parallelogram. So draw your little box. There's our parallelogram, and I'm just going to start in one direction. I'm going to work all the way around. Wherever you start at, though, keep working in the same direction. Don't go, this is parallelogram DBAC, because that doesn't show. Whenever you start in a direction in the naming, you need to continue in that direction. So I'm going to start with D, A, B, C. You can start at any of these. You can start at A, B, C, D, so on and so forth. Alright, A, B right here is parallel. So if I drew my line, I'm going to say, well, it's parallel to this side right here. So D, C. DA is congruent to its opposite side. CB. Angle CDA is congruent. Well, we know if this angle is congruent to the opposite angle. So angle ABC. And now we have segment DE here. And it's going to say it's congruent. We know that if it's gets bisected by this other diagonal, that we can say it is E, and that's a terrible looking E, EB. Alright, let's move down example 3 real quickly. Example 3, if ABCD is a parallelogram, first thing that I like to do is let's go ahead and let's draw a rough sketch of this. And start it anywhere. I'm going to start right here with my A. I'm going to work my way around in order. A, B, C, and D. It's a parallelogram. And it tells us the measure of angle A right here is X degrees. And the measure of angle D is 2X minus 3 degrees. What do we know? If you went back to the very top, these are our consecutive, so what do we know about them? They equal 180 degrees. So these two things added together equal 180. Let me say that again. These two things added together. So X plus 2X plus 3 equals 180. Alright, so let's combine our like terms. We'll get a 3X. And this should be, before I get too carried away, minus 3. So 2X minus 3. Alright, so that's going to leave us 3X minus 3 equals 180. 3X equals 183. Add 3 to both sides. Divide both sides now by 3, and that will leave you x equals 61. So now, what is it asking for? It's asking for the value of x. It didn't ask for either of the measures of these angles. It simply asked for the measure of, or what the value of x was. Alright, so now let's take this and let's move to our last page. We have here example 4, which says x, y, z, w is a parallelogram with diagonals of x, z, and y, w. They intersect at point A. So, I'm going to go ahead and I'm going to draw. Alright, so there's an attempt at a parallelogram. Alright, I'm going to go ahead. We've got x, y, z, w. So, x, y, z, and w. They have diagonals. So, here's two diagonals roughly drawn in here. They intersect at point A. So, there's a point A right here. It says XA, XA. So let me go grab a color for this. XA equals 3M. And ZA equals a 5M minus 4. Find M. So what do we know about these two pair of segments? We know from our previous that if you took this one, that they are congruent. If they are congruent, that means this equals this. 3M equals 5M minus 4. I'm going to go ahead and I'm going to move my M's over so I can get like terms. Subtract 5M, negative 2M equals negative 4. Divide by negative 2, divide by negative 2. That will leave you with an M equals positive 2. That's what it's asking for. It's asking for M. Let's draw that. There we go. It wants us to find M. So, problem solved. Moving on, example. This will be our examples 5, 6, and 7. For each one, find the values of x, y, and z. Alright, we can immediately start off, and I can say I'm going to look at the one directly opposite of what we actually have, because we know these, it's by definition, they're parallelograms, so those are equal. So our x is 80 degrees. Now we know that this angle here and whatever would be here are supplementary. If those two are supplementary as well as these, we can also say that our y is equal to the same thing as we have over here. Our y is also 80 degrees. And when we find our z value, these two are supplements. 180 minus 80 is going to leave us our z. 180 minus 80 is 100 degrees. Now, if you wanted to do a little bit deeper mathematically, once you find that this is 100, you can plug it in. You know this would also be 100. These two are a linear pair, so then you could define it that way. Otherwise, we couldn't just know that these two are supplements, these two are supplements, whatever this is, these two have to be the same. So, let's move along here and let's look at number 6. 6, I can look immediately right across from here and I can say that this value is 120 degrees. Alright, Now, we know that this, all of this whole thing, and you add it together, that these equal 180. This is 120, so 120 plus 35 plus x equals 180. 155 plus x equals 180. Subtract 155, and it will leave you with an x is equal to 25. So we have found x, 25 degrees. Now add these two, or if we're looking at this, go back to our transversals. I'm going to take a line. Let me snag a good color here to continue out. If I continue this line, continue it out, continue these up, this down here, this way. What we're looking at is these right here are going to be the same, but we know that these angles across here are congruent. They're opposite side interiors. So if we can say that, and we know that whatever value out here is going to be the same as the value out here, we can say the value that's inside will be the same value on this side. So our y is equal to whatever is on the opposite side. So let's go ahead and snag this color. Our y equals, in that case, 35 degrees. Alright, here it's getting a little bit more tricky on us. We have to, let's first look at our x, because we can say, just like what we did here, well actually we can just look at this. It's the exact same way as we did here. We have our opposite side interiors. So our x is now 30 degrees. These two are on a straight line. These two are a linear pair, z and 70. Z and 70 linear pairs, they are supplements, they add up to 180 degrees. That would leave z has to be 110 degrees. So if z is 110, this is 30, we can now find this one because we have a triangle. The sum of the interior angles of a triangle is 180. Here we have 140, so what has to go here in order to add up to 180 of 40? We can go back to just like what we did before with this x and 30, y and 35. We now have y and 40 on this parallelogram. Alright, our last example, example 8, has it drawn for us here. It's a parallelogram, WXYZ parallelogram. The measure of angle ZWX is B degrees. So I'm going to write this in here. This is B degrees. The measure of WXY is D degrees. This is a D degrees. I'm going to go ahead and put what we have right here and right here. Alright, find the values of A, B, C, and D. Alright. Let's start out with our A. And let's see what our A has for us here. Our A has the length of this segment right here being cut, which we know that this segment is congruent to this segment. This segment over here is 15. Therefore, our A has to be 15. B, all of this degrees is we can look. Here's our two congruent angles. That's why I put one arc to represent that. So let's add these two together to find our value of B. 18 plus 31. 49. Alright, now let's look at C. Let's see what it's asking us for C. We know that from above, this going to be congruent. Put two lines here since I've already got my 1. That these two will be congruent. So we know that 2c is equal to 22. C in that case equals 11. And lastly, we're looking at D. Now for D, it looks like we may have to do just a little bit more work. We know that this angle right here, let me find a good color that will stand out. This angle right here is 49. We know that these two together equal 180. So our D plus 49 equals 180. D plus 49 equals 180. Subtract 49. D now equals 131. So D is 131. And that has us wrapped up for these notes.